Hello everyone! Today we'll talk about AI pathfinding in Godot. But let's figure out why it's needed at all. So typically to get from point A to point B, you calculate the vector between both positions by subtracting one from the other. By doing that multiple times, you can easily make an enemy hunt down the player character, for example. The problem is that this equation will always give us the shortest path between those two positions. If we have a wall or similar obstacle on that path, the enemy will not be able to go around that obstacle and get stuck instead. So we need to make sure that there is no obstacle on that shortest distance line between start and end. Pathfinding algorithms do exactly that. A grid is needed based on the walkable and non-walkable areas of a level as a prerequisite. The AI can then take that grid as well as the start and end position to create a path over multiple different grid cells, avoiding those non-walkable areas. There are many different types of algorithms. The best known is probably A*, as many others are derived from it. With the resulting path, we now reuse the equation I talked about in the beginning. But instead of letting the enemy directly walk to the player character, the enemy needs to pass each cell returned by the pathfinding algorithm. So that's the theory. Now, how to get this done in a Godot game? We need the grid for the level as well as the result of the pathfinding algorithm, which in turn needs a start and end position to create a path in the first place. Godot has an easy way to create the level grid for pathfinding. We need a navigation node as well as a navigation mesh instance node as its child. The according to D nodes are navigation 2D and navigation polygon instance. Next, we need some sort of level mesh. This can be a grid map node or a number of mesh instance nodes. Levels made in Blender are of course also possible. Those level mesh nodes need to be children of the navigation mesh instance node. The hierarchy can be as deep and nested as you like. With a click on the navigation mesh instance node, we can create a navigation mesh in the inspector tab. And with a click on Bake Navmesh, the level grid used later by the pathfinding algorithm is then saved into the Navmesh of the inspector tab. Meaning you can go and save that Navmesh as a separate resource in case you want to use multiple different level grids in your game. But why would you want to do that? Well, a game might have many different types of characters. Some can swim, others can fly. Most of them might only be able to walk on land. You might have characters in many different sizes as well. All these attributes would affect the path a character can walk. So while one Navmesh can be used for multiple characters of the same type, you will need multiple Navmeshes if you have vastly different characters. Luckily, we can just reuse our setup to make multiple Navmeshes for different character types. We just need to change the attributes set in the inspector tab of the navigation mesh instance for that. For example, in agent, we can define the height and radius a character occupies, or if it's able to climb over specific walls or slopes. The Navmesh is calculated based on the intersections between different mesh instances or grid map cell meshes. That's the default behavior, but you can change it to use the intersections of colliders instead. Or both if you want to. If you need a different hierarchy for your level data, you can also change the source geometry mode to only use meshes in the scene belonging to a certain group. So now we have the prerequisite for our pathfinding algorithm. But how do we calculate the path in-game? That's what the navigation node is for. By calling the getSimplePath method with the start and end position, the navigation node will use the navmesh set in navigation mesh instance to return the path as an array of positions. Now all we need to do is walk from one position to the next by calculating the distance vector between the current position of the character and its goal position on the path. Once we get close enough to the goal, we take the next position in the path array as our next goal. You should allow a certain margin of error for passing one of the path's positions. It's always possible that a character might not be able to exactly hit the goal position due to floating point imprecisions. And that's all for basic pathfinding. Of course, you can enhance this further. For example, you might want to recalculate the complete path in certain intervals, even if the character hasn't passed its last position. That way, an enemy will be able to react to the player changing their position on the fly, making the AI much more believable. But you can also add acceleration to the velocity of the AI character based on how close it is to its target. Maybe at the start it will accelerate, then walk/run towards the target at top speed, and slow down when getting close to the last position of the path in order to not tackle the target. This is all up to you and the character you want to simulate via proper pathfinding. Anyway, that's it for today. Thank you very much for watching, and until next time, bye bye!